Hi, this is Dorsan Mertz. Welcome to ACT Math Part 7. We're going to talk a little bit more about trig. We're going to go over transformations some more, and we're going to go into the equation of a circle and the equation of ellipse and some basic logarithms. All right, some transformation rules. I just wanted to go over this again, even though we covered it last time, because it's a little confusing and it could save you some time and help you get an answer correct quickly if you can remember how things shift things. So if you have a function and you add d to it, then it just shifts the function up d units. A positive d would shift it up d units, and minus d would shift it down d units. Now, if you have the plus c on the inside of the parentheses, this is the one that does the opposite. So when it's on the inside of the parentheses, it switches things to the left. It moves it to the left c units. And if you had a minus c, that moves it to the right c units. So it does the opposite of what you expect it to do. Now, if you have a negative f of x, that reflects it over the x-axis. So it'd go from being up in the top to down in the bottom. It would reflect it over the x-axis. If you have a f of negative x, it reflects it over the y-axis. And this is, if you'll remember when we were talking about trig functions, if you put a number in front of like the sine function, it caused the amplitude to get higher. So this is a vertical stretch. A number in front of the f of x is a vertical stretch when this number is greater than 1. Now, if this number was between 0 and 1, it would compress it vertically. The opposite's true when you have a number in front of the x, between the function and the x, like if it said sine b of x, sine 3 of x, a number that's above 1 is a horizontal compression, like when we talked about the sine functions. If you put a 2 there, it would make the period of a sine function go from 2 pi to just pi. It would half it. Now, if you have a number that's between 0 and 1 here, then it would double it. Like if you had a 1/2 there, then it would double the sine function from 2 pi to 4 pi. All right, here's a question. You can see it's number 57 on this test that I pulled it from, and that means it's near the end, so it's going to be one of your harder ones, but it's one you can get correct quickly if you remember how things move the functions. So the functions y equals sine of x and y equals sine of x plus a in parentheses plus b for constants a and b are graphed in the standard coordinate plane below. The functions have the same maximum value. One of the following statements about the values of a and b is true. Which statement is it? Okay, and then we look down here and we know that this part would shift a positive a is going to shift something to the left, and a positive b is going to shift something, it's going to make something go up, it's going to shift it vertically. But if we look, nothing's really shifted vertically on this. So b, since it didn't shift it vertically up or down or anything like that, then b must be 0. And if you look down here in these answers, there's only one that has b equals 0. So if you notice that right away, you can get a as the answer in a very quick fashion. You can also see that a is less than 0. That means it shifted it to the left. So here was your original function, your original sine function, and then you just shifted it to the left. So this part's true as well, that a is less than 0. All right. Now let's look at the law of sines and the law of cosines. The law of sines, or the sine rule, is useful for solving triangles, and they don't have to be right triangles to use the law of sines. It works for any triangles. The stuff we covered last time on trigonometry, that was all dealing with right triangles. But here's all it says is that this is the little a, little b, and little c. That represents the length of a side of a triangle. And the larger numbers, that's the sine of the angle. So these are the angles, these are the sides. So it's saying A over the sine of A is equal to B over the sine of B is equal to C over the sine of C. So there's a relationship between all these sides and their angles. And then there's a law of cosines as well. It's called the cosine rule, and it's provided in a note on the ACT. I've never seen an ACT test where you had to memorize this, but anyway, it's c squared equals a squared plus b squared minus 2ab times the cosine of c. Now, if you have a problem and they give you one of the angles, that one's going to be your cosine of C. So you're going to make that your C angle, and you'll make that the opposite side your C side, and then the other two will be A and B, and it doesn't matter which one you make A or which one you make B. All right, and here is, this works for any triangle as well. The area is equal to half of A times B times the sine of C. So whichever angle they give you, that's going to be your C. Okay. All right. And this formula used to be they always gave it to you on the ACT. I have seen a test or two lately where they did not give you the formula, and you could still figure the answer out, but if you memorize the formula, you'd get it very quickly. But usually they give you that one. All right, let's do this one. It's 59, so it's near the end of the test. So this is one of the harder questions on this test. The lengths of, or at least it's one of the more complicated topics since it's trigonometry. The lengths of the triangles shown below are rounded to the nearest tenth of a centimeter. What is the area to the nearest 1 centimeter squared of this triangle? And then it gives you this in the note. It gives you how to get the area of the triangle. The area of any triangle with sides of length A, B, and C, opposite of angle measure A, B, and C, respectively, is given by 1/2 of AB times the sine of C. So we know right away this is the only angle we're given, so that's going to be our sine of C. It's going to be sine of 30 degrees. So we're going to plug that in there, and then that means this is C, the length of C. So that doesn't go into the formula anywhere, but these other two do. So it's going to be 1/2 of 4 times 8 times the sine of 30. So 1/2 of 4 is 2, and 2 times 8 is 16. And if you'll remember, the sine of 30 degrees is always 1/2. Remember, sine of 45 degrees is the square root of 2 over 2, and the sine of 60 degrees is the square root of 3 over 2. So the sine of 30 degrees is 1/2, or you could plug that into your calculator if you don't remember that. You could put 16 sine 30 degrees, and you get the answer is 8. All right, Jed is standing 10 meters from a maple tree that is 14 meters from a willow tree, as shown in the figure below, in which the measure of an angle is given. Which of the following equations, when solved for x, gives the distance between Jed and the willow tree? So we want this. We're given the length between Jed and the maple tree, and the length between the maple and the willow tree, and we got to find the length between Jed and the willow tree. All right, this one gives you the note, the law of cosines in a note, which is c squared equals a squared plus b squared minus 2ab cosine of angle C. If you look at all your answers, all we got to do is plug things into the right spot. We don't have to actually solve it and figure out the actual length. We just got to figure out how to plug everything into the right spot. So we know the cosine of angle C, we're only given 34 degrees. So that's going to be 34 degrees. We know the 10 is going to be our C because it's opposite of angle C. So we'll plug the 10 into the C part to 10 square. So that eliminates 3 choices. So now we've got it down to A and B. So since this is C, X and 14 will be A and B, and it doesn't matter which one you choose for which. But so we got X squared plus 14 squared. So far, those are the same, minus 2 x14, or this one says 10 times 14. So they plugged the C in there, and it's really supposed to be 2AB. So this one is the correct one, A. So this one just required you to plug things into the right spot. You don't actually really have to work that out using your calculator. All right. Remember, that's the law of cosines, and you do not have to remember it for the test. I've never seen it required that you memorize that. It's always given in a note. All right, let's talk about the equation of a circle. This can save you time on every ACT test I've ever looked at. Equation of a circle when the center is HK and the radius is R. So this is the equation. It's x minus h squared plus y minus k squared equals R squared. So it doesn't equal just plain R, it's R squared. Pay attention to that. And pay attention that these are always minuses. If your equation that you're looking at said plus here, that would mean you'd know that the h was actually negative. It would actually be over to shifted to the left. So um, let's do some problems where you do memorize this, and we'll go over it on a couple problems. You can see how to be helpful. In the standard coordinate plane below, the vertices of the square have coordinates 0, 0, 6, 0, 6, 6, and 0, 6. And they even drew the figure for us to save us some time. Which of the following is an equation of the circle that is inscribed in the square? So we know the diameter of this circle is going to be 6 because it goes from 0 to 6. So therefore the radius is going to be 3. And if we remember our formula, it's radius squared. So we know it's going to be 9. So we're only looking at the answers that have 9 at the end. We've already eliminated the others. And since it's in the quadrant 1, and both of these are positive numbers, we know it's got to have minus in the formula. So we can eliminate the ones that don't have the minus in both formulas. So C has pluses, so that is wrong. So it's A, x minus 3 plus y minus 3 squared equals 9. And you knew that center was at 3, 3 because, you know, that's halfway across your diameter. All right, a circle in the standard coordinate plane is tangent to the x-axis at 5 and tangent to the y-axis at 5. Which of the following is an equation of the circle? They didn't draw a circle for us here, so we're going to have to draw it ourselves, and we know it's going to touch the x-axis at 5 and touch the y-axis at 5. Here's a really ugly drawing that doesn't even look like a circle, it looks more like an egg. But anyways, it's touching the x-axis at 5 and touching the y-axis at 5. It has a radius of 5 and its center is 5, 5. So that's the origin, that's the center. And if we just plug those numbers in, remember it's R squared at the end. So we got to have an answer that has 25 at the end. So it's going to be either B, D, or E. And since these are both positive numbers, if you plug them in, it's still going to have the minuses there. So it's going to be C, x minus 5 squared plus y minus, D, x minus 5 squared plus y minus 5 squared equals 25. All right, I'm going to go ahead and talk about the equation of an ellipse. These did not used to be covered on the ACT, but I have seen them show up lately, so we're going to go ahead and review that in case you see one. It's not really that hard once you figure out what's going on. So if this is an ellipse, if A is larger, it means your ellipse is going to be larger horizontally. If B is larger, it means your ellipse is going to be larger vertically. So this one, you have a larger B than you do a A. So that's one thing we know about this. It's similar to the circle equation in that it's a minus here. So that means when you have a minus here, it's going to mean the H and K are actually positive numbers. If it had a plus here, it would mean you were looking at a negative H. If it had a plus here, you're looking at a negative K. All right. One of the following equations determines the graph in the standard coordinate plane below. Which one? All right, we see it's wider than it is tall, so we know that the A value is going to have to be larger. So we look at that and we go ahead and we can cancel out H and K. So we're only looking at F, H, and J. So the center of this circle is going to be at 3, 4. So it's at 3 and 4 here. So if we plug that into the equation, we need to pick the one that still says minus because these are both positive. They're in quadrant 1. So it's going to be this one. It's going to be F. And remember on the ellipse, it doesn't equal R squared. It's going to equal 1 always. And all these answers say 1. So that doesn't help you eliminate anything. But so it's x minus 3 squared over 25 plus y minus 4 squared over 9 equals 1. But if you just remember that if it's wider, the A value is larger, and if it's taller, the B value is larger, that at least helps you eliminate some choices. All right, let's go into logarithms just a little bit. So logarithms, the They're the inverse of exponents. So you just got to remember when you look at log b of x equals y, what you're saying is, what power do I have to raise b to get x? That's what you're doing. It's just the inverse. You can change b to the y power equals x. You can change it to log b of x equals y. All right, here's some things you might want to remember. These are some, I'll call them identities that you might want to remember. When you have log b of x times y, it's the same thing as saying log b of x plus log b of y. Similarly, if you have log b of x divided by y, it's the same thing as saying log b of x minus log b of y. And this is a little bit more difficult, but if you have log b of x raised to the y power, it's the same thing as bringing out that y and putting it in front of log b of x. So if that was an x squared, this would become 2 log b of x. You can use, now if it doesn't say a number for the b on a question, then you assume that that number is 10. That's the common logarithm, and that's what's on your calculator is the log base 10. So, all right, which of the following is a value of x that satisfies log x of 36 equals 2? So now if you'll remember, we're saying the b is the base, and it's raised to the y, it equals x. So we're going to look at it that way. So we're saying x squared equals 36. So what number squared equals 36? The answer, of course, is 6. So that's how you do that. So it's a simple little problem once you understand logarithms. All right, here's one that's a little complicated. It's in a word problem. The number of decibels produced by an audio source can be modeled by the equation D equals 10 log of I over K, where I is the sound intensity of the audio source and K is a constant. How many decibels are produced by an audio source whose sound intensity is 1,000 times the value of K? So I is 1,000 times K. So no matter what K is, I is 1,000 times more. So we can just change that to 1,000. So we're looking at D equals 10 log 1,000. You can simply punch that into your calculator if you want to. You can just punch in 10 log of 1,000. Or if you aren't comfortable using a calculator and you recognize that that log means log base 10 of 1,000, and you can say 10 raised to what power equals 1,000. You're going to know this number is 3, and 3 times 10 is 30. So either way, you get to an answer very quickly. But if you're comfortable using your calculator, know where the log is, then just go ahead and punch that in. It's pretty quick. All right. If log a of x equals s and log a of y equals t, then log a of xy squared equals what? Now, if you'll remember before when we saw that question and it said log b of xy equals log b of x plus log b of y, that's what we're looking at. So log a of xy is going to equal the same thing as log a of x plus log a of y. We know that log a of x is s and log a of y is t, so it's going to be s plus t, but now we got this square up here. And remember, when you have a logarithm and it's raised to an exponent, you can put that exponent in front of the log sign. So then you could say 2 times s plus t. So just remember those log b of xy is log b of x plus log b of y. And then we're using this one also, that log b of x raised to the y is the same thing as y log b of x. All right, that's all for now. Thank you for joining me, and I'll see you next time.